doing translation as one form of transformation. And now we are going to discuss rotations. All right, so rotations. We're going to just read the little intro they have here. Geometric rotations involve turning an object around a point called the center of rotation. When you rotate a shape, you need to define the center of rotation, the number of degrees you wish to rotate the shape, and the direction in which the rotation occurs. You can rotate an object by however many degrees you wish. Positive rotations go in a clockwise direction, and negative rotations go in a counterclockwise direction. As with a translation, the image is exactly the same size as the pre-image, so the two shapes are congruent. And can someone, in their own words, tell me how they would define a center of rotation?
Oh, it's like the point that the shape rotates around. It's like it doesn't move.
Exactly.
Correct.
Exactly. It doesn't move. It's the point that the object rotates around. If you're imagining a clock, it's the center of the clock, right? Now, we're going to rotate either clockwise or counterclockwise. So it says drawing the image after a rotation can be tricky unless you guys are excellent students like my students. After rotating on a coordinate grid, make sure each vertex and side of the image are the same distance from the center point as on the pre-image. This will ensure that the image is congruent to the pre-image. Now let me explain what that means without all that math jargon. So if we've got a shape here, shape ABC, this little triangle, little polygon, that I just made up some points and drew. If I want to rotate that, first off, in my rotation that just happened, who can tell me what my center of rotation is?
0, 0.
0, 0. It's the origin. Exactly, right there. And while we start on rotations, for now, the origin is going to always be our center of rotation. It's easy to imagine it that way, but that won't always be the case. The center of rotation will sometimes move away from the origin. Now, with my image, A prime, B prime, C prime, and my pre-image, ABC, how much farther away from the center of rotation is A prime than A? Can someone tell me how much farther away from the center of rotation A prime is than A?
It's the same distance.
It's exactly the same. And is B prime the exact same distance away from the center of rotation as B? Yes. And C prime is the same as C. So when you rotate an image, the points on the image should always be the exact same distance away from the center of rotation as the points in the pre-image. Now, have all 3 points moved the same distance in my transformation? No, actually,
No.
right? A to A prime did not move very far, but B to B prime moved much farther. So that is one difference with rotation than with translation, is that not in translation, all of our points are the exact same distance. With rotation, our points do not all move the exact same distance. Some move much farther, generally if they are farther away from the center of rotation. And then who can tell me how many degrees are made by my intersection of the axis here out of an angle? It's 90 degrees.
How much
This
what?
is a 90-degree angle here, right? Made by the two axes. So every time I rotate an image 90 degrees, it's going to go into a new quadrant, right? If I take my first image and I rotate it 180 degrees, it's going to move into the bottom left quadrant, right? Because I just rotated it 180 degrees around the axis. And you guys are going to use this polygon transformer soon. Is there any difference? Can someone tell me if there's any difference between rotating 180 degrees clockwise and 180 degrees counterclockwise?
No.
No, there's
No.
no difference. It's going to be exactly the same.
No difference.
Now, if I were to rotate 90 degrees clockwise, how many degrees would I have to rotate counterclockwise to have the same image?
270.
270.
70.
Close. 280 would be a bit off. And why 270? Because that's 3 times 90. 90, 180,
Or 360
270.
minus 90.
or 360 minus
Oh,
90.
I thought you- no.
Exactly. Did I ask all the questions I wanted to ask? They didn't all move the same distance. We did this. Yeah, I asked everything I asked. Okay, is that clear to everyone, what we've introduced with rotations? Sorry if this is a little
Yes.
jumbled. I've had quite a morning. Okay, so all I want you guys to do now is to jump onto this Desmos activity where you're going to do some rotations yourself. And as soon as you finish, you're good for the day. Tomorrow, we're going to do a more specific rotation activity that I want you to record in your notebook, okay? But for today, we're just going to do an intro to rotation on Desmos where you guys get a feel for it and do it yourself. Does that make sense?
Yes.
Cool. I am going to hang out on the Google Hangouts
Yeah.
for another 30 minutes in case any of you get confused. You can pop over to where I'm at, ask questions. I'm here for you. At 12:10, I'm going to go do some lunch. Sound good?
Yes.
All right, everyone, take off. Do Desmos. Have fun. I'm here.
Thank you, Reggie.
Yes, no problem.
Bye.
Thanks,
I'll
Reggie.
stay on. Hi.
Hi, guys. You can hang out. That's fine. Put my glasses back on.
What?
All right, I haven't done these in a few days, so let's do them again.
Is it called the point of origin? What's it called?
The center of rotation.
Center of rotation.
Now, how are they going to let me be the teacher and not the student? Oh, I'm still recording and presenting. Hilarious. All right, end of lesson.
Why is there only